Hello, and thank you for joining us for the notes on Module 2B, Day 3, looking over geometric sequences and series. So our initial work on our notes is going to be calculator active, but we will discuss how to approach items without a calculator in case you need to be able to do some things without a calculator. So a geometric sequence is nothing more than a sequence that has a common ratio between consecutive terms. So if I have a sequence a sub 1, a sub 2, a sub 3, all the way to a sub n and going on infinitely, that sequence is considered geometric if there's a number r such that the ratio of two consecutive terms in the sequence is constant, right? And we call r the common ratio, and r can't be 0. We can find the nth term of a geometric sequence by using this formula that a sub n is going to be the first term times the ratio raised to the n minus 1 power, right? And that way, a sub 1 is going to be that first term times the ratio to the 0 power, right? Because n minus 1 is equal to 0 if n is equal to 1. So let's look at some examples. Find the common ratio for each geometric sequence. So we're told this is geometric. So I'm going to look at the ratio between the two terms. So to get from 3 to 9 and from 9 to 27, I know I'm multiplying by 3. Therefore, my common ratio is 3. If I look at my next sequence, I try to find my pattern, see what's going on, and it seems like I am multiplying by negative 1/5 each time, and so therefore my common ratio is negative 1/5. Now, do you realize that we're asked to find, so we technically should show the work? How do we get negative 1/5? We got negative 1/5 by taking 4/5 divided by negative 4, and that would be negative 1/5. That's another way we can tell our common ratio. And if we see the command term find, then it is necessary for us to show some work. Continuing. The 15th term of a geometric sequence with the first term 20 and the common ratio 1.05. Well, if we want that 15th term, we're going to use the formula that we just talked about. We're going to say, hey, a sub 15 is going to be that first term 20, and then times 1.05, that common ratio, raised to the 15 minus 1 power. Right? Basically what that's saying is we need to multiply by 1.05 14 times to get from our first term all the way to our 15th term. So that's going to be 20 times 1.05 to the 14th power. And so I'll come to my calculator and go ahead and make that computation. 20 times 1.05 raised to the 14th power. And to 3 decimal places, that's approximately 39.598, or I could say 39.599. All right, so it's going to be important that if we're not asked to give our answer to 3 decimal places, and different courses, different environments will have you give a different level of accuracy. For the College Board, the answers need to be given to 3 decimal places. And it's okay if you truncate or if you give the rounded answer. Looking at our next, the 12th term of our geometric sequence, right? So we want to figure out the 12th term, and that 12th term is going to be 5, our first term, times our common ratio raised to the 11th power. So we got to figure out, well, what's the common ratio to get from one term to the next? All right, and it looks like that's a typo there. That should be 45 because 5 times 3 is 15, right? 15 divided by 5 is equal to 3, right? 45 divided by 15, that's equal to 3. So our common ratio is 3. So we can say 5 times 3 raised to the 11th power. and that gives us a value of, looks like 885,735. All right, so just using our formulas and recognizing our pattern that if we have something geometric, we're going to have a common ratio. So the sixth term in our given sequence, all right, so we got to figure out what's happening each time. That ratio will be -2 divided by 6, which is -1/3. Right, and we can double check, is that the same as 2/3 divided by -2? And that is the case. So our sixth term, right, let's say u sub 6 is going to be that first term times our ratio raised to the n-1 power. Using my calculator, 6 times my ratio, -1/3, raised to the 5th power, and that gives me -2/81. That's an exact answer. That's fine to give. And of course, we could give it as a decimal answer, which is -0.025 if we were going to 3 decimal places, or -0. Let me scroll down here. -0.024. Right? It's okay to round, or it's okay to truncate. Okay. Continuing with our work. The fourth term of a geometric sequence is 192. The eighth term is 49,152. How could we figure out the common ratio? Well, what do we know? A sub 4 times r squared would be a sub 6. A sub 4 times r to the 4th would be a sub 8. So that means that 49,152 divided by 192, right, is going to give us r to the 4th, and that's 256. So if I take 256 and I raise it to the 1/4 power, that gives me my common ratio, and that common ratio therefore is 4. All right, what's my first term? Well, I know that my fourth term is going to be my first term times my common ratio raised to the 3rd power. So my first term has to be that fourth term, 192, divided by my common ratio raised to the 3rd power. And so that means that my first term was 3. All right, now, of course, if you knew that 4 to the 3rd power was 64, we could do that a little bit more quickly. All right. If we want a formula for a sub n, the nth term, a sub n is going to be my first term times my common ratio raised to the n-1 power. All right. And if I want my 7th term, a sub 7 is going to be 3 times 4 to the 6th power, but I could also get it by saying 4,952 divided by 4, because I could take my 8th term and divide it by the common ratio to get to my 7th term. So we see 3 times 4 to the 6th power. We see 49,152 divided by 4. We should end up with the same answer, and we do. That's 12,288. Okay. In the next video, we will continue with these notes, but that's an initial look at working with our geometric sequences and their given term. Okay. Thank you very much for your time.